Here we have this system of equations to solve. It looks like there's three variables, x, y, and z, and three equations. So substitution looks like it might be out since none of these variables are super easy to solve for, despite the fact that I do realize this first equation, they're all even numbers, so I probably could divide everything by -2 and isolate this x. But that seems like an awful lot of work, so let's make a different approach. Let's go ahead and use elimination. And it looks like our z's might be pretty easy to eliminate because it looks like we have a positive 6z and a negative 6z right here that we could just add up my first and third equations. And then we could probably do something with maybe the first and second equations. They have opposite signs already. So first, let's tackle the first and third equations. Let's go ahead and just straight up add them. We have a plus 6z and a minus 6z. So let's add them up. So negative 2x and negative 3x is negative 5x. And then positive 6y minus 5y is positive y. And then 6 and 14 makes 20. So for my first and second equations here, 6 and 4, they already have opposite signs. Looks like the least common multiple of 6 and 4 should be 12. So we could run a 2 through the top equation and a 3 through the second equation. And that'll give a positive 12 and a negative 12, which will get my z's to cancel out. So let's go ahead and rewrite those equations by multiplying the first one by 2 and the second one by 3. So negative 4x plus 12y plus 12z equals 12. And then run a 3 through the bottom. 15x minus 15y minus 12z equals negative 60. So I can add these up now. The z's will cancel. That was the point of doing that. So it looks like I have 11x minus 3y equals negative 48. So I have this equation and this equation. They have x and y only. So I have a nice system with two equations and two unknowns. So let's go ahead and slide this over a little bit and I'll rewrite these equations. Negative 5x plus y equals 20. And then 11x minus 3y equals negative 48. Okay? So it looks like probably our y's will be the easiest to solve, so we're not multiplying by big numbers. So the y's already have opposite signs, positive and negative. So I'm going to run a 3 through that top equation to get our y's to 3y, and then they'll cancel out. So let's go ahead and run a 3 through. So negative 15x plus 3y equals 60. My second equation is unchanged, so I'm just going to go ahead and rewrite it. My y's cancel. Again, that was the point of doing that. So negative 15x and an 11x makes a negative 4x equals 12. So when I divide both sides by negative 4, my x equals negative 3. So I've kind of whittled this away. I had 3 equations with 3 unknowns, and then 2 equations with 2 unknowns, and then I was able to solve for x. So let's go ahead and dump this value of x back up here into one of these equations. So negative 5x plus y equals 20. So negative 5x, my value of x, plus y equals 20. So 15 plus y equals 20. So when I subtract 15 from both sides, it looks like my value of y will be 5. So I have a value for x, and I have a value for y. So we need to kind of go back to the beginning and choose an equation and solve for z. Let's go ahead and dump it back into this first equation. Let's rewrite that real quick. Negative 2x plus 6y plus 6z equals 6. Okay? Well, I know that x is negative 3, and I know that y is 5. So let's go about solving now for z. So 6 plus 30 plus 6z equals 6. So I'm going to combine like terms right there. And then just go ahead and subtract 36 from both sides. 6z equals negative 30. So when I divide both sides by 6, z equals negative 5. Well, now I have all three of my values. I have my x over here, and I have my y and my z. So let's go ahead and write our solution as an ordered triplet, where my x value comes first, my y value comes second, and my z value comes last. So here's this ordered triplet, which is the solution to this system of equations.